Hello MGA, my name is Rishiraj Dutta. I am the Capacity Development Lead from Asian Disaster Preparedness Center in Thailand. Let me first welcome all of you to the MGA Rapid Prototype Development Challenge 2021. And I'm very happy to deliver a session on long-term drought risk management initiatives in the Lower Mekong, providing all of you with knowledge on ongoing research and innovation in the area of drought monitoring and forecasting. Therefore, let me take this opportunity once again to welcome you, and I hope you will find the session useful. Thank you. Now, as I mentioned, my session today will basically focus on long-term drought risk management initiatives in the Lower Mekong. Now, if you look into the entire Southeast Asia, the region is agrarian region, so which means most of the countries are agriculture dependent. There are over 115 million hectares of agricultural land in the region that mostly includes major crops like rice, maize, oil palm, natural rubber, and coconut. However, the region is also highly prone to several natural disasters that includes drought, floods, tropical cyclones, earthquakes, and others. Over a period of time, until recently, it has been observed that drought has become a more frequent phenomenon in the region, bringing in a direct impact on food security, as it is accompanied by prolonged dry spells. Now let's look into the Asia-Pacific regional risk scale. On an average, the annual losses that incurs in the region is over 675 billion US dollars, of which 60% of the losses comes from drought, so which is nearly 400 billion US dollars. Now, if you see the sequence of disaster events in the Asia-Pacific region, on an average per decade, the number of natural disasters are on an increasing trend. And most of these disasters are found to be climatic events. Now coming a bit into the drought risk in Southeast Asia, the region has actually experienced three major El Nino events. One that occurred in 1982, the other that occurred in 1997, and the third one that occurred very recently, that is in 2015. The strongest ever El Nino that was recorded was during the period of March 1997 to February 1998. While 1982 and 1997 El Nino occurred due to the maximum sea surface temperature anomaly in the Eastern Pacific, the 2015 El Nino occurred mainly due to maximum sea surface temperature anomaly in the Central Pacific. 2015 El Nino was also considered to be the warmest El Nino in the last 35 years, as reported by NASA. The global temperature in 2015 went up by 0.13 degrees Celsius, which is higher than 2014 as per previous record. Now, when we compare the 2015 El Nino with that of the 1982 and 1997 El Nino, what we observe is 2015 El Nino was not as strong as compared to 1982 and 1997. However, 2015 El Nino was considered to be the warmest ever recorded in history. 40% of the region experienced temperature of more than 0.5 degrees Celsius. Now, let's look into the special pattern of El Nino. If you look into the 1982 and the 2015 events, there is more or less similarity in terms of the concentration of the El Nino. So it was more in the Indonesian region, and to some extent also affecting the Mekong region. So the Indonesian region as such has experienced severe to extreme drought conditions, whereas the Mekong region did experience some level of severe drought conditions. But if you look into the 1997 El Nino, the entire concentration of El Nino was found to be in the Lower Mekong region. and to some extent in the Indonesian region. So which means the region experience severe to extreme conditions in the Lower Mekong. Now, looking into the drought risk management for Lower Mekong, we do understand the regional priorities, which has been well established and identified through a joint study between United Nations ESCAP and the ASEAN Secretariat. And these are some of the 5 priorities that has been identified based on the final outcome of the joint study. The number 1 is building drought resilience through programs and policies. Number 2, need to customize the best regional and global practices. Number 3 is strengthening drought risk assessment and early warning services. Number 4, fostering drought risk financing markets. And number 5, promote cultural prevention by enhancing adaptive capacity to drought. Now, from Asian Disaster Preparedness Center's perspective, we do have our priorities of action to address some of these needs and gaps for the Lower Mekong and also for the ASEAN region. So what are our priorities? So we have identified 4 priorities of action. Number 1 is need for real-time drought monitoring and early warning system in the Mekong region. Need to customize the ADPC's regional drought monitoring system in the countries. Strengthen the customized drought tools with further validation of products using local data. And last but not the least, enhance the use of Earth observation data for monitoring and analysis. Currently, in Asian Disaster Preparedness Center, we have an ongoing flagship program, which is known as Surveyor Mekong. Now, this is a program which is a joint initiative of NASA and United States Agency for International Development, USAID. The entire program as such is known as the Surveyor Global Program, and this Surveyor Global Program has different sub-programs. So that as of now, there are 5 sub-programs which are running globally, and each of these programs that are run globally are designated in the form of global hubs. So you can see from this map, there are 5 global hubs. One is in Surveyor, one is in Latin America, which is called a Surveyor Amazonia. The other one in West Africa, which is called a Surveyor West Africa. The third one is in Eastern and Southern Africa, known as Surveyor Eastern and Southern Africa. The fourth one is in the Mekong region, that is hosted within Asian Disaster Preparedness Center, known as Surveyor Mekong. And last but not the least, the fifth one is in Isimot, that is in Nepal, which is known as the Surveyor Hindu Kush Himalaya. So through this Surveyor program, we have been providing necessary training and capacity building support, as well as demand-driven services to the countries. And one of the requirements that came out from the different countries is to come up with a near real-time drought monitoring and forecasting tool. And based on this requirement, the Mekong Drought and Crop Watch has been developed for the region. Now, what is this Mekong Drought and Crop Watch? Let's take a look. So it's a real-time drought monitoring system, which has both the nowcast and the forecast capabilities. The system provides 5-kilometer drought products, and it provides 6 satellite-based drought indices and 20 model-based indicator and indices. Now, how does this work? The Mekong Drought and Crop Watch, it runs on a framework known as the Regional Hydrologic Extreme Assessment System. In short, we call it as RIAS. Now, this RIAS, it works on an integrated modeling platform that includes an integration of a hydrological model, which is known as the Variable Infiltration Capacity Model, and the other a crop simulation model, which is known as the Decision Support System for Agro-Technology Transfer, which is known as DSAT. Now, this combination of the models integrates different kinds of available Earth observation data to produce the different drought products. Now, these drought products are not only produced for the current situation, but it also provides products for the next 1 month, 3 months, or 6 months period, which is basically the forecast products. Now, how these products could be used? These products could be used not only for decision-making purposes, but this could also be used for research purposes as well as for other scientific issues. Now that we have a regional tool already available in the region, which is live and operational, now we are in the process of further customizing these regional tools at the regional and national level. Now, what have we done at the regional level? The Mekong Drought and Crop Watch has now been customized at Mekong River Commission. Now, Mekong River Commission has been using the products of Mekong Drought and Crop Watch in the form of weekly forecasts, providing the forecast for the entire Lower Mekong Basin. Now, the system uses the 5-kilometer drought products, both for nowcast and forecast. Then we have also customized the system in Vietnam, which has been made live and operational within the Vietnam Academy of Water Resources, and the system is known as the Vietnam Drought Portal. So the current system, however, is using the 25-kilometer drought products. Now we are in the process of upgrading these products to 5-kilometer drought products. However, the system is providing both nowcast and forecast information for some of the selected provinces within Vietnam, which are highly prone to drought situations. So as I mentioned, we are now in the process of upscaling the system, not only in the current provinces where it has been deployed, but it is also being further customized and upscaled to other provinces that are prone to drought conditions. The work is being jointly carried out between Survey Mekong and NASA Jet Propulsion Laboratory. So when we look into the benefits of this system, this is one of the case examples that I'm presenting here. So you can see the system is now live and operational and is being used by the Vietnam Academy of Water Resources for providing necessary advisories to the farming community. The information sent by Vietnam Academy of Water Resources goes to the Ministry of Agriculture and Rural Development, who in turn send this information to the District Agriculture and Rural Development in the form of advisories and bulletins that is being further disseminated to the farming communities to inform them about the conditions in their area. Apart from that, the information is also shared within Prime Minister's office and is also being used by the Ministry of Natural Resources and Environment. Further customization of the system is also currently ongoing in 2 countries, that is in Cambodia and Myanmar. In Cambodia, the customized version of the Mekong Drought and Crop Watch is known as the Cambodia Drought Information System, whereas in Myanmar, the system is known as the Myanmar Drought Information System. The system has been fully live and operational in both the countries using 5-kilometer drought products for nowcast and forecast. It is also using all the 6 available satellite-based drought indices and 20 model-based indicators and indices. However, as part of its customization at the country level, we are still in the process of further calibrating and validating the informations so that it meets the required needs of the countries for effective operational decision making. So this is all from my session on the drought risk management initiatives in the Lower Mekong. Thank you once again. Thank you very much.